Okay, let us discuss problem number 5.18. So first draw this diagram and then we will discuss the problem. This height is h, so I can write it here. So this height is h basically. Now you are able to see, I think. Now this problem is slightly lengthy one, but we can do this one. Concepts are very easy. Only thing is slightly it needs a geometrical calculation. So geometrical optics many times needs the calculation of angle between angle in a triangle, how the normal will go. So this is more related to geometry, and that's why sometimes they call it geometrical optics. Optics that is related to geometry. So ray tracing is more about the geometry. So sometimes it helps a lot if you have a geometrical idea that is important. You remember those things. Have you done this one? Not yet? Okay, draw. So you see there is a medium 2 or lake, you can say. So there is a lake. In this lake there is a stone S that is kept. So S is a stone, and if I draw a normal from line point S, this cuts the surface of lake at point M. Now there is a person sitting here, or maybe a standing here. This person looks this a stone, and it is given this person looking the stone at an angle of theta. So angle of vision of this person makes an angle theta with the normal on the surface. This is given in the problem. Now the question asks, what is the height from the surface of pond where the image will be shown of this stone? Now the problem, if the problem is slightly ray is coming paraxial, the things is very easy. If the line of incidence, line of angle of sight makes an angle 0 degree, paraxial rays are there and a stone is here, things are very easy. We can apply formula n2 minus n1 by r is equals to n2 by v minus n1 by u. This formula is basically valid only for paraxial rays. Now in this case, angle of vision makes an angle theta that is given in the problem. This is equals to 60 degree. Theta is not so small, so it makes an angle quite finite theta. If it makes an finite theta, I cannot apply the grazing incidence, so paraxial rays approximation. I have to do some geometrical work. So now you see, if this eye sees this stone somewhere here, so let us say how this is forming. A ray coming from a stone comes at point P, and then after refraction this goes to the eye. In the next figure I will show you again, there is another ray that is coming from here and this goes to the eye. So I am only considering the first ray. So there are two rays I have to consider for any image to be formed. So this image I cannot form due to the only one ray. So what we have done? We have shown only one ray, and if I extend this ray here, and if I drop a perpendicular from, so this is the image S1. Now you cannot form this image S1 only from one ray. Basically in the next diagram I will show you later, there is another ray that also meets at point S1. So there are two rays that is meeting at point S1. So this is the image. Now if I draw perpendicular from here to the surface, let us call this height is H dash. Let us say if I drop a normal from here, this is laterally shifted by distance L. Let us call this point as M. So distance between N and ML is L. Now refractive index of air is 1, refractive index of pond is the water is N. The water inside the lake is refractive index N. Now you see length L, this length I can found if I see this triangle. So in this triangle, that is the triangle NSP, I can find this distance. Now if I subtract this distance that we can find from this triangle, so this length L is basically MN is nothing but NP minus MP. So NP minus MP. Are you getting or not? Because I am interested in two triangles. I am interested in this triangle. I am interested in this triangle. So there are two triangles. Using this triangle I can find this distance, total distance. Using this triangle I can find this distance. If I subtract these two distances given from two different triangles, I can find what is this distance. So this distance is nothing but this distance minus this distance. Are you getting or not? So L is nothing but Pn minus MP. Now Pn is what? So if you use this triangle, so this distance is given as h dash. So this distance, this angle is theta. Because angle of incidence theta, so this line and this line are parallel, this is cutting, so you will have alternate angles are equal. So this is theta, so this also has to be equals to theta. So this angle is h dash. So this, this height is h dash, this angle is theta. So this will be what? Opposite equals to adjacent, tan theta. So you can also write in this triangle or in this triangle, you can find this height is h. So this will be h tan theta 1. So let me write in triangle SMP, I can write what is the value in. So let us see the triangle SMP. So this triangle SMP, I can write tan theta 1 is equals to this side by this side. So tan theta 1 is equals to PM by H. So PM is H tan theta 1. So this is PM, that is H theta 1. Now if I see triangle this S1NP, that is the triangle S1NP, I can write tan theta is equals to Pn by H dash. So Pn is this and H dash this. So Pn is H dash tan theta. So I can place this value L is equals to H tan theta 1, that is the from here, minus H dash tan theta. So this is H dash tan theta. Now if I, so this is the lateral shift. Now theta 1 is known, theta is known, but theta 1 is not known. So I can find theta 1 using a Snell's law. I can apply a Snell's rule at point P. So I can write N1 sin theta 1 is equals to 1 into sin theta. So you see, if I apply N into sin theta 1 is equals to 1 into sin theta. So sin theta 1 is sin theta 1 sin theta by N. Now if I know the sin theta, I can find what is the tan theta. Why I am interested in tan theta 1? Because here I have tan theta 1. So I need tan theta 1. Tan theta 1 is, you need sin theta 1 is this, that is the sin theta y n. So this height is n square minus sin square theta. So tan theta 1 becomes this height divided by this base. So that is sin theta divided by n square minus sin square theta under root. Now this L will be h tan theta 1 minus h tan theta. So tan theta 1 is this. From here I can put the value of tan theta 1, and this is h dash tan theta. So this is the lateral shift L. Okay, put the value and let us copy this one, and then we'll discuss next. Okay, now let us consider the next line, that is the next ray. So we have considered only one ray. We have said we can consider another ray also. Let us consider another ray that is coming from S, and this hits this surface somewhere here and then goes something like this. This means now this surface hits here, that now this makes an angle of refraction, that is theta plus d theta, and angle of incidence is theta 1 plus d theta 1. So the angle of incidence is here theta 1. Now let us consider a ray that is going to the eye. So this means eye is extended object. I can consider more than one ray that is going to the eye. So let us consider the next ray that is going to the eye, that emerge from here at theta 1 plus d theta. So the angle of incidence on this surface is theta 1 plus d theta 1, and the I can correspondingly angle of refraction is theta plus d theta. So we will show you. So let us copy this one and then we will discuss the next diagram. So whatever we have said, we can put into this diagram. So you just copy this diagram and then we'll discuss further. So it will take time. Let us copy this one. So this means, you see, from S we have already considered this ray that is at theta 1. Now we will consider another ray that is at theta 1 plus d theta. So this angle is theta 1. This angle is theta 1 plus d theta 1. So if this angle is theta 1 plus this theta 1, so this angle has to be theta 1 plus d theta 1. Now this angle is necessarily theta, so this angle is theta plus d theta. Now these two rays, this ray and this ray is going to the eye, because I can collect more than two rays because this is a extended object. So let us draw this diagram and then we'll discuss further. And now things are very easy once you have understood all this. Okay, done. So let us keep copying, and I'm telling you once again we can write L by only I have to replace theta plus d theta. Now next task is to find again L. What is the lateral shift? I can again use this length is same as now this triangle NP dash minus this length, that is the NP dash minus MP dash. So now L again I can write NP dash minus MP dash. So this will give you L, NP dash minus MP dash. Now I will not do any calculation. If I simply replace theta with the theta plus d theta, I should get the same result that I have get earlier. So we have what will be the lateral shift? I have the expression. If I simply replace in that expression theta by theta plus d theta, so you see lateral shift I have this expression. So if I simply replace theta plus d theta, I will again get the lateral shift. Because what is happening this time? Only thing that is a change, that is theta becomes theta plus d theta. So if I replace this by theta plus d theta, I will have L is equals to h sin theta plus d theta divided by n square sin square theta plus d theta minus h dash tan theta plus d theta. So if I put in this function, this is the total one function, if I place theta in as replace theta as by theta plus d theta, I will get the lateral shift again. So let us plug this theta plus d theta value and I will get the lateral shift. So you see in this case lateral shift becomes something like this, h sin theta plus d theta divided by n square sin square theta plus d theta minus h dash tan theta plus d theta. Now if you see these two function, I have to have L equal, either I find L from this, from here, or I can find L from here. I should get the same thing, that is the I can equate these two equations. So I can either write L is equals to this, or I can write L is equals to this. This means I can equate these two equations. If I equate these two equations, so let us write and then we'll discuss. So you equate yourself. So that is h tan theta by n square minus sin square theta minus h dash tan theta is equals to h sin theta plus d theta. Only you have to replace theta by d theta plus d theta. Now you solve for h dash. So using this expression, if you solve for h dash, it will come something like this kind of expression. So if you solve for h dash, it will come something like this. Solve for h dash yourself, you will get the same thing. Now have you solved this one? Now you see the upper part is what? If I assume this is sine theta plus d theta, so this is a function. So if I assume this is a f theta, that is the sine theta by n square sin square theta, this is a f theta, then this is f theta plus d theta. That is, I have to replace theta by theta plus d theta. So this is f1 theta plus d theta. Now again, if I tan theta is a function f2, this becomes f2 theta, this becomes f2 theta plus d theta. So if you see f1 theta plus d theta minus f1 theta, so divided by f2 theta plus d theta minus f2 theta. If I divide up and down by d theta, both sides, so I will have h, this is nothing but f1 dash theta, and this is what? f2 dash theta. So f1 is this, f2 is this. Now this becomes d by d theta, that is the differential d by d theta of this function divided by d by d theta of this function. If d theta goes to 0, this means if the two rays are emitting at very small angle. So if d theta goes to 0, this limit becomes into differential. This is a complete mathematics. When you have delta x goes to the 0, fx plus h minus fx divided by h, this fh goes to the 0, I have f dash x. Same thing I am applying here. Now this is your task. If you differentiate the up one and if you differentiate the bottom one, you should be able to get this result. So you see this result, copy this result and differentiate yourself, and you verify yourself whether you are getting this result or not. So let me bet for 5 minutes. So take 5 minute time after even switching off this video. You just do yourself and verify yourself whether you are getting this result or not. You have to differentiate this function. You have to write u by v. So the upper differentiation is in the form of u by v, and tan theta differentiation is easy slightly. Tan theta is sec square theta or minus sec square theta. I think this is a sec square theta. I don't remember. You have to find it out. So this is a sec square theta as I think. We will discuss the next problem. This problem is pretty good problem. Pretty good in the sense that in this case, first point is angle of incidence, that is the I, that is the angle by I seeing, that the general case is not a paraxial rays. This is the angle by some angle, finite angle. In this case, theta is equals to 60 degree, and that is very logical. In real life, this happens. We does not always see normally. So if you are standing over a pond and you are seeing an object that is far away from you, so the angle of incidence or the angle of sight, line of sight, will not make 0 degree angle with the normal of the object. It will always make a finite angle. That is the point. So this means in this case I can find what is the lateral shift L as well as what is the apparent height shift h dash. If you plug the value of h dash in equation 1, you can find L. You see, if you plug the value of h dash here, you can find what is the L. Because, so this means you can find what is the lateral shift and what is the apparent shift in the vertical direction. So you can find these two shifts basically. What is the apparent lateral shift? What is the apparent vertical shift? So horizontal as well as vertical. So now you see, if you have a paraxial rays light, paraxial light is going, paraxial rays is going, object only shift in the vertical direction. There is no shift in the horizontal direction because light rays coming at a 90 degree angle. But in this case, light rays coming with a that makes a horizontal angle also. So this means there will be a horizontal shift as well as vertical shift both. So you have to see this important point. In this case, now you can verify yourself. If theta becomes 0 degree, what you should expect? So let us check. If theta becomes 0 degree, so this becomes 1, this becomes 0. So this becomes n to the power 3 by 2. So this becomes h by n simply. And that is the case, if you remember, apparent height shift, if the angle of incidence is 0 degree. So if you remember mu2 minus mu1 by r formula, so let me write in the next page. So let me take another page so that you can have some idea. So you see, if theta goes to 0 degree, what will happen? We will have hn square divided by, so this becomes the denominator nq. So this will be h by n. So this is the, so this means height h. Now even if you, so this means you have a object, you are looking from top, this height h dash will be nothing but this will be h by n. So apparent shift, if you remember this formula, apparent shift is this height, that is h minus h by n. So this is the apparent shift delta x, that is h into 1 minus 1 by n. In books they write h by 1 minus 1 by mu. So this is the apparent shift in the case of, so this is the same result that you remember always. So apparent shift, if the rays are paraxial, you are getting this shift. So you are getting the same result if you put the theta is equals to 0 degree. So this is a special case. For this equation, theta is equals to 0 degree. This becomes a special case. I will advise this should be discussed in the class, because this is a special case. We derive generally mu2 by v minus mu1 by r, mu2 by v minus mu1 by u is equals to mu2 minus mu1 by r. From, if I took the r is equals to infinity, I find mu2 is equals to mu1 by v is equals to mu by u, and therefrom we discuss the shift, apparent shift. But I personally feel it should be discussed from this problem. It should be discussed this problem, and then there should be a special case in which it should be shown there is a case in which I will have vertical shift is h by mu. Okay, we'll discuss the next problem. This problem is slightly lengthy problem, but good problem.